There we go.
Yeah.
Someone's got to come home. You are live.
Okay. Well, welcome everybody. Those of you who are joining us via the internet, and those of you who are with us this evening, appreciate your being here. Before we introduce the speaker, just want to kind of keep you up to date on what we've got going, what we've been doing, and what we've got going coming up. Some of you remember that we had a creation weekend 2 weekends ago at First Baptist Church in Winfield, and we had about, what do you think, Zach? 50 or 60 adults, somewhere in there. And we had 24 kids in the kids program, which was really good. Pastor Fielding and the folks up there were very gracious and wonderful hosts, and I think it went really well. In fact, they expressed a desire to have us come back at some point. So we were very happy with the way that went. We have our zoo program coming up, and signups are started, right, Scott?
We are full.
Okay, so if you'd like to get on the waiting list, how fast did that fill up?
Yeah, that's a week.
Oh, it filled up in a week. Okay. So if you'd like to get on the waiting list, or if you sign up now, you will be given the first opportunity in the fall tour, correct?
That is correct.
Okay. So April 28th and 29th, the Zoo Day is, but also we will be at the Homeschool Expo in St. Charles. We'll have a booth there, and that's from, I think Thursday night is a free night, right?
Thursday night is a free
Thursday night is a free night, and then Friday and Saturday it's you have to pay admission to get in, but we'll have a booth there. If you're planning on coming to that, come and see us. We'd love to see you. Creation Research Society, our friend Joel Brown, who's the director down there, they are actually having their national meeting here in town at Missouri Baptist University. It is Thursday, July 24th through Saturday the 26th, and they are seeking volunteers. They need 2 or 3 volunteers each day, including the Wednesday before, to help pack welcome packets and do name badges and all that. So we're going to be sending an email out about this if you'd like to volunteer for that. There are some, you get a free registration for the entire conference, including lunch Friday, Saturday, and a picnic dinner on Saturday if you sign up to volunteer. So we're going to be sending information out via email on that. We are also working with Fellowship Church of Wildwood, and they have a school there called Living Water. And Scott and I had a meeting with the folks there last week, and it looks like we're going to do a creation day at the school on a Friday. Encourage the parents to come for that day as well. But then we'll have a Saturday event where we're going to encourage the parents to come to that Saturday event. So we're still working all of that out, but it sounds like an exciting opportunity, and that'll take place in October. So we've got a few things going on, which is good. The Lord's blessing us here. So last thing, if you're not on our email list, there's a clipboard in the back there. Give us your name and email, and we'll put you on it. And online, if you'd like to get on our email list, info@mocreation.org. So info@mocreation.org. So with that, I'm going to introduce our speaker. He's our geology guy, Zach Klein. And Zach, tonight, as you can see from the screen here, the presentation is Show Me Geology, and he's going to tell you all about evidence of the flood in Missouri and where you can find it and how you can learn from it. Right, Zach?
Sounds good.
All right. Please welcome Zach Klein.
Thank you, Marv. Make sure this works. All right. Marv already introduced me, so I'll skip through that. So, quickly, a roadmap of what we're going to look at this evening. This is a different talk than I normally get to give because I'm talking to a group of who I assume are already pretty convinced creationists and folks that are comfortable with that way of thinking. And so what I want to do is I want to take a look at a big topic, the geology, the geologic record of the state of Missouri, where we live and where our organization is based, and see how we can put some of the biblical history that we learn about in a lot of creation science venues and conferences and materials, and how can we apply that to some stuff that's maybe a little closer to home than, so let's say, the Grand Canyon, for example, as much as I love that. So what we're going to do is we're going to look a little bit at Missouri's geology, what's here and where it's at. We're going to talk a bit about the different ways, what we call models, different ways of putting together Earth history and how that contrasts between biblical history versus, of course, the secular evolutionary view. We're going to see how the major periods of the Bible's history, how they intersect with the model of geology that we're going to try to build out. And those major periods are creation to the flood, so the pre-flood world, the flood itself, of course, which is a major topic that we talk about a lot, and then the post-flood, what happens after Noah leaves the ark and bringing us up into the modern era. And then we're going to try to wrap this all together into some sort of a cohesive model, I'll say, of all of these different features and what we can learn about them. Now, a little bit of Geology 101, just so that we all know some of the terms I'll be throwing around. The three basic types of rocks. Okay, geology is about the study of rocks, essentially. And those three basic types are, of course, igneous and sedimentary and metamorphic. Igneous rocks, think volcanoes, think stuff that starts off in a molten state and then either erupts or cools underground. Sedimentary rocks, those are the rocks that are formed from sediment, as the name suggests, usually through water, but also through wind. Particles, essentially particles that come together to create sedimentary rocks. Metamorphic rocks, won't talk too much about them this evening. Metamorphic rocks are rocks that have been changed from one form into another. That's metamorphosis. And so these rocks could have been sedimentary at one time, and then through heat and pressure, other processes, they are metamorphosed into a different type of rock. A simple example of this would be marble. Marble is a metamorphic rock. We use it for sculptures and so forth. Marble is metamorphosed limestone. So limestone, which is a sedimentary rock, is changed into marble through various processes, and it has different characteristics than the limestone it came from. Those are the big categories, though. All the rocks that we're going to talk about will fit into these. Mostly we're going to be talking about sedimentary and igneous rocks because that's what we have the most of. There's a little bit of metamorphic rocks in Missouri, but not that much. And most of it, honestly, is going to be this stuff, sedimentary rock like limestone, which we can see in almost every road cut that you see around St. Louis. Now, I need to talk a little bit about the geologic column. Now, I gave a whole presentation on the geologic column some time ago, and I think most folks here were present for that. The geologic column is the observed sequence of rock types found all around the world. That's all it is. It often gets conflated with evolution because evolutionists will interpret this stack of rocks as being a portrait, a panorama of evolutionary history. But the geologic column was found before evolution was invented. So it's not correct to say that the geologic column is an evolutionary idea. Evolution, in fact, came along later on and alleges to provide an explanation for the geologic column. But the fact that different rock types were being found in particular orders with particular fossils, that was being understood even before Charles Darwin. And I'm not going to talk all the details of how we build the geologic column, but it is a real thing, and it's very useful in terms of learning about how different rock types interact in an actual location, right? What kind of rocks you find on top of other ones and below other ones. And that's what you need to do if you want to try to build a model of what happened here. Okay, why do we have sand here, followed by limestone, followed by shale, for example? That's a pretty common rock sequence that we find around the world. The geologic column helps us to map those out and see those relationships. And so, yeah, that's already made that point. It's often associated with evolution, but the origins of the geologic column actually come from long before Charles Darwin. So we can throw out that connotation. We're simply talking about the rocks that are in the real world in a particular order and how do we explain them. And this order is very practical because we find very different kinds of rocks as you move up or down through the geologic column. very different types of material, different content, different fossil content, and so forth. And this picture here, with, these big famous names like Cretaceous and Jurassic, all the way down to the Cambrian and then the Precambrian stuff. That's actually a very high level view. Here is Missouri's geologic column as mapped out by the Missouri DNR, their geologists there. And you can see it's pretty detailed, right? They've got all these individual formation names and descriptions. Now, you don't need to memorize this. There's no quiz. But this is the kind of stuff that I like to look at, right? This helps me figure out where I'm at when I'm looking at a particular road cut, and I want to figure out what formation am I looking at. This is super helpful, and it works. Now, we have to talk a little bit about geography. Where is Missouri? Well, we're kind of smack in the middle of the North American continent. This is, of course, an exaggerated topography, but you see the big picture in that we have a lot of mountainous terrain to the west. We have some less impressive mountainous terrain out to the east, the Appalachians and so forth. And then we're kind of here in the boring Midwest plains where, not a lot of famous geologic features tend to be known from this area. But that's where we're at, right? So we have this mostly flat-lying topography. Yes, we have the Ozarks and so forth, but, you're not going to get snow at the peaks of those things, right? So overall, it's a pretty flat topography, and that's all right. If we zoom in on Missouri itself, we can start to see that even though we're essentially just a Midwest kind of Great Plains state in many respects, there are actually some distinctions we can draw. So, for example, a lot of the stuff we're going to be talking about, we're going to find down here in this pink section. This laser doesn't point on the screen. This pink section here, the Salem Plateau. This is essentially the Ozarks for Missouri, and this is where you're going to find lots of rolling hills, lots of caves, and lots of exposures of rock. It turns out it's a lot easier to see rock if it's above the ground, right? When it's below the ground, you walk on it, you don't know it's there. And that's kind of the case when you go up to the green section there, the Till Plains. We'll talk about that a little bit at the end. That relates to the Ice Age. You don't see a lot of rock out there at all. It's just grass, just fields. And that's because there's no uplift. The rock is just down under the surface. And there's no places where it's been pushed up to be eroded and to be exposed like we have when we get down to the southern half of the state. We'll talk more about this later on. This little splotch of red or dark purple right there, that is where we have our igneous rocks, our volcanic rocks in Missouri. And we'll talk about those actually pretty soon here. Now, this map is just showing they call it physiographic, like the big geographical, geological regions of Missouri. We can now phase this map out. This is actually a map of the bedrock, the actual rock types that are found. And notice the maps kind of reflect each other, right? So they're measuring different things. This is focused more on topography and watersheds and so forth. But you switch over and you can see that the geology controls all of that. So geology, the rocks control your watershed. They control where your springs are, where your caves are, where your fields are going to be, where your productive agriculture is going to be. It's all driven by the rocks that are underneath that part of the state. So you can see there's a nice correlation there. And we're going to be talking about several locations around the state. A lot of stuff around St. Louis because I live there. It's convenient. And some other things that are a little farther away. Not so much in the north, just again, because there's not as much exposed up there. But we'll talk a little bit about it. And that geologic column we were looking at earlier, this is essentially all these colors correlate to that geologic column, right? So this orange stuff, these are Ordovician rocks. The dark red, those are Precambrian rocks. And by the way, I forgot to hand these out. Let me see if I have them. I brought a small handout for everyone. Let me see if I actually have it here. You know what? I'm pretty sure I left it in my car. Oh, well.
Give me your keys.
You know I parked, right?
Yeah.
All right, in the back seat,
Okay.
under the armrest.
Okay.
Those are those time scale cards from Marcus. Thank you. All right, so we're going to get you a little cheat sheet that'll help you follow along with some of these things. All right, let's talk a little about worldview, because what we're going to do now is we're going to start looking at a whole set of geologic features and fossils and so forth. And all of these things, if you go and look up in a geology book about the state of Missouri or a textbook on earth science or whatever, you're going to find explanations for all these things. Right? They're going to have a nice cohesive story, cohesive on its own terms, right? They're not going to overtly contradict themselves, right? They're going to tell you a full story going from the origin of life and the origin of the earth before that, origin of life, evolution, and these long ages of time that built up all these rocks and fossils. And it's important to recognize that science is not it's not a completely sterile enterprise, right? Scientists like to think of themselves as, they operate on purely empirical, right? Purely empirical basis. They perform experiments, they get results, they publish the results. But the reality is that all scientific models, and this is what, when we're talking about the history of the Earth, we're talking about models. We're not talking about something you can put in a test tube. We're talking about a reconstruction of a whole bunch of ideas and events that need to be put together into a storyline, and that relies on some worldview assumptions. One of them is there a supernatural, right? Do we allow supernatural causes? Is intelligent design and even a valid hypothesis to consider, or is it ruled out a priori? Is there an accurate record of the Earth's deep past? That's something that every mainstream secular scientist would completely deny. I mean, most of Earth history takes place before anything can be written down, because humans show up at the very end, right? Now, as Christians, we that's not where we stand, right? We believe that there is a record of the Earth's past that does, in fact, take us back to the very beginning of creation. That's a major worldview difference. Are the laws of nature constant? Has the past always been like the present? These are just examples of things that you can't test this empirically. You have to decide what you think about this before you can go in and perform your experiment or do your research, right? Now, a scientific model, I'm using that term a lot today, is a set of ideas that help us explain evidence or data in a cohesive way, right? You can go out and make a lot of measurements and publish spreadsheets, and it doesn't help anybody, right? To be useful, you've got to put it into some sort of a model. You've got to put it into a framework so people can actually use it to make predictions or go look for mineral resources, or maybe seek to overturn some older idea. You have to combine this stuff together into a cohesive fashion. And every model is going to involve a combination of theory, fact, and some assumptions about the world. And that's where our worldview comes in. And as we all know, because we deal with the creation topic all the time, since the early 1800s, the scientific establishment has largely settled upon an evolutionary model of Earth history. It's not something that's being debated. When you read a geology book, they're not trying to prove evolution to you. It's just assumed. This is how we came to be. This is how the Earth came to be. And they just are going to go out and apply that to what they see, right? And of course, this model is naturalistic, and it assumes slow, gradual changes over long periods of time. And that is true both biologically, and it's true with geology as well. So that is the conventional secular model. And of course, the Bible presents us with another set of data, another set of evidence that needs to be considered, which tells us that God has actually interacted with the earth, that he created all things, and that he has interacted with the earth since creation, through the flood in particular, but other ways as well. So to form a biblical model of Earth history, if we're going to set aside the secular evolutionary model for a moment and consider a biblical model, it's not enough just to say that the evolutionists are wrong. We have to be able to account for what we see in light of Scripture, right? That's what a biblical model does. The biblical model doesn't just say, no, the evolutionist is wrong about this rock. The biblical model says, here's where this rock fits into what the Bible tells us. And that's what we want to do here. We want to actually be able to set out a model. And all models, by the way, I think I say this later on, all models are, we say, tentative. They could be wrong. In fact, they probably are wrong. Every model has some element of truth and some things that were kind of guesses and may need to be corrected in the future. But what they allow us to do is they allow us to take things we see in the real world that the Bible doesn't directly tell us. Right? I can't go to a rock outcrop and say, the Bible says this rock was formed in Noah's flood. It doesn't say that. But the Bible does tell us about a global flood, which would have had tremendous geologic effects. And if we look at that scientifically and try to build a model out of it, we can start to say, oh, this rock here, where it is, it actually makes sense in light of what the Bible tells us. And we can start to build out this biblical model of Earth history. And it's going to contain many of the same theories, facts, and observations that the evolutionary model does. Things like the geologic column. The geologic column is used by evolutionists. It's used by creationists as well, because it's simply a set of observations about where you find certain rocks in relation to each other. And so a biblical model is going to account for the geologic column. It's going to account for the fossil record. It's going to account for all of these things. It's going to do so, however, in light of the Bible's history. And I think we all know this, but I just wanted to give some framework around what I'm going to be talking about, because what I'm going to be doing next is looking at a whole bunch of examples of rock features and rock formations and fossils and so forth, and giving you my current understanding based on what I've read, what I've studied about creation geology and the basic framework that most creation geologists hold to, and how these things would fit into that, right? And I'm not telling you that this proves creation. I'm not telling you that the Bible requires this. In other words, anything I say from this point on could be wrong and the Bible is still true, okay? Because what I'm going to lay out for you is a model. It's not truth. It's a model for how we can put the facts that we see in the earth, how we can place them into the Bible's history. And we might learn new things, make new discoveries, overturn old ideas, and that's going to change. And that's okay. But what I hope to show you is that the biblical model works, that it actually makes sense of a lot of things. In some places, it makes a lot more sense even than the conventional evolutionary model. And there's some areas where I might say, I'm not quite sure how that one fits yet. And that's okay. This is how science works. Science works by having questions, starting off with questions, right? And then through a combination of gathering data and forming theories, you can try to answer some of those questions. And that's what we're going to try to do here. The handout that I gave you, the little time card, and I think there's some more up here if you didn't get one. It's essentially a version of what you're going to see on this slide. We're essentially taking the geologic column and we're mapping it. You'll see on one side of the stack of rocks there in the middle. Let me grab my copy here so I can point to it. You'll see on the left-hand side, the old Earth conventional, radiometric ages that are assigned to these different periods of Earth history. And then on the right-hand side, you're going to see a biblical alternative. Now, again, it's important to understand this is still a model, right? The Bible doesn't mention these rock formations. It doesn't mention these geologic eras. However, this is where most creation geologists tend to see the big biblical periods of history: creation, the flood, and then the end of the flood and up to Babel and the present. So keep this card handy. It's very useful if you're visiting a museum, if you're looking at a textbook, you're reading something about geology, you're wondering, oh, this is a Mississippian fossil. Where does that kind of fit into the biblical story? This gives you just a place to start, right? It's not infallible. It's not scripture. But a lot of creation geologists and paleontologists will hold to something similar to this. There's a little bit of a debate, especially over the very top, that yellow section there. There's some debate over, where do you draw the end of the flood? But this represents the view of a lot of creation geologists, and it's not my invention. This is something that I'm simply taking advantage of. So I'm going to go put those labels on there as well. And you're working with a 6,000 to 10,000 year date for creation. I think probably 6,000, but we give ourselves a little bit of leeway there, some of the manuscript differences. And then we have the beginning of the flood around 4,500 years ago. The flood lasts only 1 year, so that means a big chunk of our geologic column is being formed very quickly in the space of 1 year. And then we have a few thousand years since the time of the flood, taking us to the modern era. So I'm not going to explain how we came up with all this. That's a whole other presentation. But I'm going to show you how it works when we start looking at the geology of our great state of Missouri. So let's move right into that. We're going to begin with Creation Week. Now, Creation Week is a really fascinating topic to think about. We had Hannah gave a presentation on day 4 and understanding the creation of the firmament and so forth. Day 3 is where we have the creation of the land. So that's the first mention of geology in the Bible. It's Genesis 1, verse 9. Let the waters below the heavens be gathered into one place, and let the dry land appear, and it was so. It's a verse that's very easy just to read right across it. However, if you're thinking like a geologist, this is actually a very interesting statement, because what it's saying is that something happened. The relationship between land and water shifted. So the water was gathered to one place, and the land appeared out of the water. So when land appears out of the water, geologically, what we see that as is that's uplift. That's land being pushed up out of the water flowing away, being gathered to one place. So when geologists think of uplift, we think of things like volcanoes, and even supervolcanoes. Now, that might not be something you associate with Creation Week, but hear me out here, because the volcanoes of Missouri are very, very interesting indeed. As I mentioned earlier, our volcanic rocks in Missouri are all in this red blotchy section in that kind of southeastern corner of the state. That's the San Francois, I guess how you pronounce that. This is the region where we have mountains. I mean, I've been to the west. I'm sorry, that's Those are not mountains, but they are very interesting because those rocks are unlike anything else you're going to find in Missouri. Most of these rocks relate to something called calderas. Now, calderas are essentially gigantic volcanoes that are so big and so violent that they can never form a volcanic mountain. Volcanic mountains are formed because the volcano keeps erupting and lava and ash pile up and create the cone, right? That's how your typical stratovolcano like Mount St. Helens forms. A caldera is so violent that the whole mountain, if there was one, blows up, okay? And the rocks all throughout this region, that scale there is 15 miles. This is a good block of southeastern Missouri. All those rocks are either in the caldera or they're from lava and ash that came out of that caldera. Now, you're probably thinking right now, like, why are you putting this in creation? Just hang on. So we have a lot of volcanic activity happening, a lot of igneous rocks, lava, ash, and so forth coming out in this area, and it makes some of the most beautiful scenery that you're ever going to see in Missouri. Tom Sock Mountain State Park is a beautiful place to visit and see some of this. The rocks that you see here, this sort of red speckled rock there, I think that's the highest point. Yeah, that's the highest point in Missouri. If you ever go to the highest point in Missouri, it's kind of a letdown. It's just like a trail through a forest, and like technically you're a foot higher above sea level than you were over there. But there's no vista, no view. There's better places to get a nice panoramic view in that area. But that's where Missouri's highest elevation is. Rhyolite lava is the type of rock that you find out there. It's this reddish, pinkish color with these white crystals, and it is the most explosive form of lava. In fact, we don't see rhyolite happening or being erupted at modern volcanoes. It's only associated with supervolcanoes like Yellowstone National Park or these supervolcanoes here in the San Francisco Mountain area. And it's a very beautiful rock. And sometimes you find places, this is still from Tom Sock Mountain, and then this is a picture from Hughes Mountain Natural Area. It's in the same region. It's also called Devil's Honeycomb. And notice these kind of semi-hexagonal columns. So this is what lava does. If it has time to cool, if it's insulated, it'll actually form columns of lava. Usually we see that with basalt lava, which is a darker color. But here it's with rhyolite lava, which is kind of rare. And this is another beautiful area, much better panorama than Missouri's highest point, actually. These are all in the same region down there in that southeastern corner of Missouri. You also find welded tuff, which is essentially ash and volcanic debris, bits of rock that are fused together into it's not quite pumice, although it's similar in some ways. And this can also be found in Johnson Shut-ins. It can be found all across the area. Johnson Shut-ins, by the way, which is another beautiful place to visit. By the way, how many folks here have visited these places? Tom Sock, Johnson Shut-ins, Elephant Rocks. We'll talk about that later on. Yeah, so a lot of you have been there, right? Johnson Shut-ins is really cool because the shut-ins, the rapids and all the streams and everything is formed because these different igneous rocks weather at different rates. So some erode faster than others, and that's what creates this complicated maze that the water runs through. And so I'm going to, I'll talk about Elephant Rocks again as well. Elephant Rocks, same idea. It's igneous rock. It's not volcanic because granite cools underground, but it is connected to the same volcanoes that we were talking about a minute ago. Okay, so with igneous rocks, if it erupts out the top of the mountain or onto the surface of the earth, that's called lava. If it cools underneath the earth, which will often happen underneath a volcano, then you can get rocks like granite. Now, elephant rocks themselves, I want to quickly answer a question that comes up a lot because when people ask how elephant rocks formed, it's a loaded question because there's the rock itself, the granite, and then there's the famous elephant-shaped or oblong boulders that usually people are wondering about. Now, those boulders are actually post-flood, okay? And we know this because we can still see them forming. These boulders are formed because granite fractures in a very peculiar way, and just because it has weaknesses within it that water will soak in there, and then winter freeze and thaw cycles will start to break apart the boulder, and we can see this happening all over the earth. It's not something that's exclusive to elephant rocks. In fact, I've seen rocks that look identical to elephant rocks in Arizona. So this phenomenon really happens whenever granite is exposed to temperature oscillations where it can freeze and thaw. Okay, so the boulders themselves are formed. They're still forming. We can watch them form. We can observe it. They're still happening today. But the granite itself, I'm arguing, is from before the flood. Now, I'm going to explain why I put all that before the flood. But in a very high level, Genesis chapter 1, verse 9 tells us that the earth, the ground, the dry land emerged from the water, right? It appeared out of the water. And all this volcanic uplift is associated with, mountain building processes, with uplift processes, things that move the ground up. And this is not the only place where this happens, but it is a very interesting place where we do see this intercontinent, mid-continent volcanic activity, which is producing a tremendous amount of volcanic material. And now you might say, why is that from creation? Well, we're going to see that in just a minute here. Let's talk about the flood. All right, so the flood is described in a bit of detail in Genesis chapter 7, and we all know the story, of course. And the flood begins with the fountains of the great deep being broken up, and then the waters prevailing and transgressing over the land. Okay, well, here's where things get really interesting, because if this is the case, geologically, when water transgresses and when an ocean flows over the land, one of the first things it does is it begins to erode. It cuts things away. It washes things away. It abrades things away. And it creates something called an unconformity, where you have maybe a stack of layers here, and then the ocean comes in or the water comes in, and it will start cutting down through those layers and creating a surface that doesn't quite line up with where the rock layers were originally. Okay, that's what's called unconformity. So these are associated with erosion. Well, right at this boundary, right where, if you look at your card, right where we have the beginning of the blue stuff, right, the pink and blue right there. I think it even says the beginning of the flood. That's this right here, all around the world, we find an erosional unconformity, a brink where the rocks below are very different than the rocks above. Yes, Beverly?
Could you talk just a little slower?
I will try, but we might be here all night. So I'll do my best.
Anybody else would be happy with that?
So
Face yourself.
an unconformity is where we've had erosion and we have a gap of time. Now, how much time depends on a lot of assumptions, but we have a gap of time between the rocks that were below and then they were cut down, and then something gets laid down on top of them. Now, this great unconformity, as the name suggests, it's great because it's found all over the earth. Every continent has this great unconformity, and it's at the same place in our geologic column. It's right there between the Cambrian rocks above and the Precambrian rocks below. And above the unconformity, this is a picture from the Grand Canyon. So you can see this kind of pinkish rock below, about up to the gentleman's shoulder there. And then there's a very different rock type, a sandstone, in the shelf that's kind of overhanging. This boundary is found all over the world. So here it is in Wales. So we have, you can see the rocks here are tilted at an angle, and then the rocks above are horizontal. It can be seen in Wisconsin. In this case, the rocks have been tilted up on their side, but you can see there's the ripply rocks below, and then there's the more massive rocks above it. And we can see it as well here in Missouri. And the best place to see it is down here at Fredericktown, so going south on 67, where we have igneous rock below, called ignimbrite, and then we have this boulder layer, and we have sandstone on top of that. Okay, this boundary, that the rocks above and below will be different in different places, but the boundary is almost always present. Now, the boundary can be anywhere. It could be at the top of a mountain. It could be down under the ground. But we find this boundary all over the earth. It's recognized by geologists for a long time. It has been recognized by them. And what's fascinating in terms of our biblical model is we only find animal fossils, plant fossils above this line. Now, evolutionists think, well, that's because life originated somewhere at that gap, right? But thinking about this biblically, we know that during the flood, all flesh died of terrestrial animals, and a lot of marine animals would have died as well. And so when we see a widespread erosion surface all over the earth, above which we begin to find sedimentary layers with fossils in them, And we don't find fossils below that boundary. You find microfossils, bacteria, but you don't find animals. If we're looking at this from a biblical worldview, it looks very interesting because this would suggest that the rocks below this boundary were formed before living things were made. So now you can see why I was putting all that stuff in Creation Week, because all those volcanic rocks we were talking about, they are in the same age group as the rocks here below our great unconformity. And they have no fossils. You don't find fossils in rocks that are below that boundary, but you do find them above it. And so most creation geologists would point to this line as the beginning of the flood. And just to give you a sense of how impressive this really is, the rock types that are in this layer of boulders here, I should get another picture of that, this boulder layer, these rocks are believed to only form in the core of very tall mountains. And so right here in this location is believed to be the basement of a mountain that could have been as tall as the Himalayas, could have been as tall as Mount Everest. And it's been bulldozed away, and all that's left is those boulders. So incredible erosion. Now, of course, evolutionists would interpret this as being very slow erosion over hundreds of millions of years. But again, putting that aside, looking at this from a biblical perspective, this is telling us about an event that was so violent that it pulverized entire mountains, leaving nothing but rubble. And above this erosion boundary is where you begin to find the remains of animals and plants that perished most likely during the flood. Here's another picture of that same boundary. You can again see the rock types are very distinctly different. We have that kind of finer grain, light colored rock below, which is again another igneous rock. And then we have the sedimentary rocks, the sandstones above it. And some places you can see where the sand has been pinched around these boulders. So it's a very dynamic environment. Interestingly, there's also another reason why we think that all those igneous rocks, all those volcanoes are from before the flood and probably from creation. There's no fossils, so it seems like there weren't living things, which that works. Day 3 of creation, no living things were created yet. Also, the igneous rocks, the volcanic rocks, were clearly cold rock. They were hard rocks. It could be broken into boulders. You can't break lava into boulders. So that's another reason to think that these there's a time gap between creation and the start of the flood. Now, the Bible tells us that during the flood, the waters prevailed. It tells us that several times they prevailed over the land, covering ultimately the highest mountains, and it caused widespread death of certainly animals living on the land, but also that would, by implication, it would also include a lot of animals that lived underwater. And so that brings us to our fossil-bearing rocks, which would be from the beginning of the flood and the middle of the flood all the way to the end of the flood. And there's a number of, and fossils are always found, virtually always found in sedimentary rocks. It's hard to preserve a fossil in lava for hopefully obvious reasons, right? They burn up. In metamorphic rocks, the process of metamorphosis usually destroys any fossils if there were any. So sedimentary rocks are where you find your fossils. One of the big sedimentary rocks that we have around the earth, including here in Missouri, is sandstone. And like the name would suggest, it's just literally a stone made of sand. But these sandstones that we find in the layers that we think are from the flood, that's important because the rocks change as you go through this stack. And the sandstones that we find in these blue and green sections are incredibly widespread. So for example, the Tapete sandstone, which if you listen to any creation material on the Grand Canyon, you may be familiar with that name. It's the sandstone layer actually right on top of that great unconformity we talked about a minute ago. It's called the Tapete sandstone, but the Tapete sandstone can be traced across all of North America. If you look at that map there on, on your right-hand side. That represents the Tapete sandstone and other sandstones that are very similar and that are at that same boundary, that Cambrian, Precambrian, great unconformity boundary right there. And we can find that same boundary and that same sandstone here in Missouri. It's called the Lamont sandstone. One of the challenges in doing creation geology is that most geologists aren't thinking globally. So the same rock type will be called a different name, a different formation from state to state. And that's very common. But when you look at where those rocks land in our stack, we see, well, they're in the same place in the stack. They're in the same place in our column. So the same rock type. In many cases, they have the same fossils in them. They're probably part of the same formation, the same sandstone, the same limestone deposit. Another example, not quite as impressive, but similar, is the St. Peter sandstone. This picture is from Pacific, Missouri. If you go out west, you kind of towards Rolla, that direction, you'll see these white cliffs, and it's a fascinating rock. If you put your hand on it, it's kind of rub, it's going to come right off in your hand, and it's like fine beach sand in your hand. Pure quartz. It's used for glass production. Still is mined and used for that today. This, again, is a very widespread unit. This is a map of where the St. Peter sandstone is known to show up. And it covers, you can see northern Missouri. It covers a good bit of most of Iowa. It covers all of Illinois, up into Minnesota, Wisconsin, and so forth. Now, the St. Peter sandstone is also interesting because it has these gigantic crossbeds. Now, a crossbed, think of a sand dune, right? Sand dune, you have the sand coming up and going down, right? If you cut a cross section through a sand dune, this is what you see. You see these layers of sand that go up at an angle, stacked one on top of the other, and that's your crossbedding. All right. Now, these crossbeds in this particular place where I took this photo, these are from sand dunes or sand waves that were at least 30 feet high, which is pretty big. And again, this is just a very interesting and unusual rock formation that we find over a very widespread area. Another rock type, a sedimentary rock, is dolomite. Dolomite is interesting. By the way, most of the rocks you see, like in a road cut around Missouri, are either limestone or dolomite, one or the other, unless you go down to those volcanic rocks, right? And dolomite is all throughout the rock record, especially in these what we think are flood layers, and no one knows how it forms. It's a carbonate rock, so it's like limestone, but it has a lot of magnesium in it, and we know how to make it in a lab, but the conditions where you make it in a lab don't match real world conditions. So we still don't know exactly how you form this stuff, and yet it's found very extensive throughout the rock record, very common here in Missouri. Another one of the sedimentary rocks that's really important is chert. And in fact, if you're ever wondering what Missouri's state rock is, it's called mosarkite, and it's a type of chert. By the way, another type of chert that you might be more familiar with is agate. So it's basically a rock that's made of silica, and it's silica with other minerals in it that give it different colors, and the different mineral composition will give it a different set of colors. So chert, you'll notice chert because it's a very waxy rock when you feel it. So you see like thin beds of a white rock interbedded with limestone above and below. You rub your finger on it, it feels kind of waxy. Flint is actually in the same family as chert, so it can break apart and make nice arrow points and so forth. Very interesting rock, also a little bit mysterious how it forms. Limestone, however, is the big one for us here in Missouri. That's a lot of our sedimentary rock, a lot of our rock is limestone. And limestone is also where we find most of our fossils. I've got a sampling of common fossils that we find here in Missouri. Notice that all of these animals are animals that live in the ocean. They're all marine animals. There's like one dinosaur that's been found in Missouri, and it probably was washed in, probably didn't live here. It's a pretty unusual site. But we have lots and lots of ocean-dwelling creatures. Now, I think this is obvious. We don't have an ocean here anymore, right? So what this illustrates, and by the way, the one in the middle there, the crinoid, that's not mosarkite. I didn't fix that label. I'm sorry. The crinoid. I was editing my slides last minute, and that one slipped through. The crinoid is Missouri state fossil. Mosarkite is not. That's the rock. But these are all marine fossils. And what's fascinating, I think, and again, this is one of the areas where the biblical model, it just works nicely, is that you find ocean fossils on the land everywhere, including the highest mountains. Something, it's a talking point we often use, but it's really impressive. That's where you don't find ocean fossils in the ocean where you think they should be. If ocean fossils simply represent what happens to animals over millions of years that live in the ocean and they get fossilized, well, then why do we find the ocean fossils in the ocean? We find them on the land, universally. And that speaks to the idea that the oceans cover the land, which is exactly what the Bible tells us. I'm going to skip this section. If you want to talk to me about finding fossils, I can talk about that afterwards. Now, one thing about limestone that we need to talk about, because limestone is both a great evidence of the flood, but historically it's also been a challenge to the flood. And the reason why is because limestone it's made of mud particles, which are usually microscopic, very tiny particles that make up limestone. So it's marine mud, ocean, seafloor mud is the idea. And the conventional understanding of how limestone forms requires long periods of time and very calm, they say, placid water, not strong currents, because strong currents will pick up those mud particles and just wash them downstream, and they'll never actually be able to settle down to the bottom. So limestone, in fact, there's a relatively, well, not famous, I guess, but one early creationist who left the creationist fold and became an evolutionist. And this was a big part of the reason. He just said there's just not time. You can't form limestone quickly enough to in the flood. But creationists have pointed out there's a lot of features about limestone that actually suggest that it is put down much more rapidly. One is the kinds of fossils that we find in it. We don't tend to find fossils of communities of organisms that lived in this like seafloor. Like, it's not an active seafloor. You're finding bits and pieces, broken pieces of animals. Other things about this limestone is that you don't find the extensive burrowing that you expect from living creatures digging through the sediment and overturning it, which is what happens in modern seafloors. So the fossil content's different, the nature of the sediment's different. And some of the fossils that we find in this limestone, and this is a particular formation of limestone that I've been studying called the Kimswick, we find very large fossils. This one I'm going to highlight here is it's called a nautiloid fossil. It's a long shelled squid. Essentially, the animal's like a squid that lived in a long cylinder or cone-shaped shell. And some of these guys got to be really big, like 20 feet in length. I've not found any quite that big, but maybe 3 or 4 feet in some cases. That's more or less what it would have looked like when it was alive. Very interesting animals. And what's interesting about them in particular is that when we find them in this particular location, I've gone through and I've been measuring them, measuring their compass orientations. And what you notice is that they line up. They are all buried in consistent or mostly consistent orientations, which is not something that happens when animals just die in the ocean and settle out on the bottom of the floor, the seafloor. When you have long objects like these shells that are lined up in a consistent direction, that suggests that you actually have pretty fast-moving currents that are bearing these things. Also, they don't appear to just be of the same age. You've got young ones and older ones all mixed together, so it seems like they were buried as living animals, not simply animals that died of natural causes. And so what this suggests is that the conventional model for limestone formation, which is that you have these mud particles sort of raining down in water that was moving very slowly, this might not be accurate, because that would not explain why we see these fossils buried with consistent orientations. And so a newer model, a newer view of how limestone forms, this is not just a limestone at shale, these rocks that are made of mud, sedimentary rocks made of mud, is that rather than forming through the sort of rain of particles, that many of them were actually formed with fast-moving water. And what you see happening here, trying to illustrate anyways, is that these individual particles, they actually clump together into larger particles that are called floccules. And remember how I said that the problem with forming limestone is that if the water is moving, it washes away the particles? Mm-hmm. Well, when they clump together like this, that solves that problem. They actually fall out, and they fall out pretty quickly. And this is actually, and we've seen this happen. They've done laboratory experiments where they can validate this model actually works, where mud particles will stick together and become larger, heavier particles that will fall out in fast-moving water and start to form your layers of limestone, or layers of mud, such as limestone. And that fast-flowing model does explain why you would find these long cylinder-shaped fossils with consistent orientations. This actually is a case where they're being carried by a current, and that current is both depositing the mud and burying these animals simultaneously. And this is not a creationist idea, by the way. In fact, this idea comes from mainstream secular geology, and they've been doing laboratory experiments, flume experiments, and so forth, showing that you can indeed build up mud layers quite rapidly in high energy conditions. So you can see this is a diagram from this paper, I think it was in Science magazine, which basically laid out essentially what the creationists have been saying, that rather than this old model of particles settling out slowly and building up layers this way, that instead we have what are called migrating ripples in fast-moving water that builds up our layers of mud. This is a quote from that article, mudstones. And mudstones is that it's a big category. It includes shale, it includes limestone. It's any rock with particles that are smaller than sand. So sandstone, you're beyond the range of mud, but if it's smaller than sand, then we're talking about some sort of mud rock. And so mudstones can be deposited under more energetic conditions than widely assumed, requiring a reappraisal. That means a reanalysis. We got to look at this over again of many geologic records. And what they actually say in this article is that for a long time, for decades, geologists will use limestone or use shale to say, here's a place where we had very low energy conditions for a long period of time. Like that's how they know. They know that it's slow because it's limestone, because it's mud. And mud can only form in slow or still water, slow moving water. And now they're saying, well, that assumption's wrong. So everywhere we pointed to mud as an evidence for a long time, we've got to look at that again because it doesn't prove that anymore because we've now demonstrated in the laboratory how it can form very quickly. Okay, but here's an interesting twist. So I've talked about how there's evidence that this limestone and these mud layers are put down quickly. Well, now we have to talk about something else because it turns out that some of the fossils that we find in these same layers are actually structures that are believed to be reefs. So we think of coral reefs today, like the Great Barrier Reef, right, where we have these corals that grow and they die and new colonies grow on top of each other and they build out these big frameworks, right, and they create habitats for all kinds of animals. Well, it turns out that in some of these same layers, we find fossil reefs. Now, they're not coral reefs. There's coral in them, but they're made of different marine animals than coral typically. But this is from a paper that just came out actually last January. I've been following this work for a little while now, and there are these interesting places in these same limestone layers, which I'm telling you formed rapidly, right, during the flood. But then we find these areas where there appears to have been many generations of growth of animals in one place, which requires way more than a year, much longer than the year-long Genesis flood. This is a picture of the location. I've been able to visit it a few times, and it's very spectacular. There's really interesting fossils, and the researchers there have mapped out the different organisms and different animals live there. Some animals live there to kind of stabilize the sediment, and then they die off, and then animals colonize on top of them. They've got these different growth stages of the reef. And the question is, how do you grow a reef in a year-long Genesis flood? Like, how does that even work? I don't know. I'm still waiting. And I included this because I wanted to make a point. I'm still going to go through, we're almost done here, but I'm going to go through it and I'm going to say like this fits this part of the flood, this fits in this time after the flood or whatever. There are lots of areas where there's still questions. I don't know how you answer that one. I'm not sure how you get a reef in flood sediment. There's possibilities. Maybe it's not truly a reef. Maybe it's been misidentified. Maybe it is a reef that's been broken apart from some other location and carried into position. That's a possibility. But this is not the only place where you find this. There are fossil reefs found all around the world, all throughout the rock record. And they've been pointed to by anti-creationists to say, see, you cannot explain these layers in terms of the flood because we know you cannot grow a reef in a few months or a year during the flood in high energy conditions. Reefs need time, they need space, they need calm conditions so they can establish themselves. How do you explain that? And I'm not sure yet. I'm still looking into it. I'm not giving up. But I just include that because part of the process of science is you do run into questions, you run into puzzles where the answer isn't obvious. And I can't go to a website and just punch it in and find the answer. And that's okay, right? That's how science works. We have lots of good reasons to think that these layers were put down during the flood. And that evidence is still there. It's not going away. So how do we explain this kind of stuff? It remains to be seen. But that is how model building works. When you are building a model, you don't have all the answers. You have some starting assumptions. You have some evidences that seem to say you're pointed in the right direction, you're on the right track, and then you've got to deal with the challenges that come up and figure out, well, how do you account for this in our biblical model of history? All right, let's look at a couple more things. Meteor impacts. You probably don't think of meteor impacts in Missouri too much. It's not something we're famous for. A famous meteor crater is, of course, meteor crater in Arizona, and that's clearly a post-flood event. There was an asteroid that struck the Earth, created this very beautiful crater, very well preserved. Notice the crater's square. Somebody pointed that out to me. I didn't notice that before. It's not a round crater. It's actually a rounded square that apparently has something to do with the fractures in the joints in the bedrock that were peeled up. But it turns out we actually have evidence of meteor impacts in our great state of Missouri. And these impacts are really interesting because they're part of something called the 38th parallel structures. And the 38th parallel, just that line of latitude, where there are a whole bunch of these structures, these zones where the rocks have been broken up and overturned, and they're all in a line right around that 38th parallel. And three of these, the Wablu Osceola, which is right here, the most westward, Decaturville in the blue, and then Crooked Creek in the pink there, have all been confirmed by geologists that yes, these are meteor impacts. So those are the ones that I'm focused on here. And the reason why I find this, it's interesting by itself, and I visited all these locations, and you do find some really interesting rocks. They recognize these craters initially, I didn't scale up that circle, by noticing these circular patterns in the drainage, the rivers bending strangely and the watershed acting differently. And they begin to realize, oh, there's actually a circular structure here. The crater is gone, but the bedrock was affected by the impact, and that bedrock is affecting how the drainage patterns work and what kind of rocks are exposed. This is in eastern Missouri, Springfield area, or western Missouri, sorry. These are kind of famous, these Weablu eggs. They're essentially balls of sediment that formed somehow through the impact. They're found around the impact zone, and it's not entirely clear what formed them. We find rocks that have been shattered, broken apart. So this is the Weablu structure. Moving eastward, we have the Decaturville structure, which again, you can see circular patterns in the topography there. This is actually one of the more impressive ones because you can actually see one of the row cuts here where these limestone layers have been tilted up, and you can walk. If you follow one layer, it's horizontal here at this end of the row cut. It will vault up, and then it twists, and you're looking at the underside of the layer. So here it's just part of the wall, and then you keep following, and it just comes up at you. It's like you're looking at a wave of rock flowing over you. And this is the zone where there was a shock wave that went through these sediments, and it essentially is a frozen wave of sediment, of rock. You find these spherical nodules there, again, similar to those the Weablu structure. We find shattered rocks, which aren't super visible in this picture here. So what's interesting about this? Well, there's a couple things interesting. I'm going to mostly skip over this, I guess. But there is separately good evidence that there was a large number of catastrophic meteor impacts that happened during the flood. And a very simple one is if you look at the moon. If you look at the moon, you'll notice these big black splotches, right? The lunar maria. Mm-hmm. Those are impact craters. We should have Hannah give us a talk on the moon sometime. Now, what's fascinating about them is that they're on the side of the moon that faces Earth. So whatever hit the moon to create those craters had to fly by the Earth first. Probably not one thing, probably a swarm of things. And there are well over 100, 200, I think the latest number of confirmed impact craters or buried craters that take place in this zone where we think the flood was happening. So these impacts would have certainly added to the energy going on during the flood. It's possible they may have had something to do with how the flood began. Perhaps God used these impacts to initiate some of the events that resulted in the flood. So we don't know exactly how this all works, but it is definitely an example of catastrophic processes going on during the same time frame of the Genesis flood. And I don't know this is my slides, but I'll very quickly say this. Those 38th parallel structures, the reason why I got so interested in them is because you see how they're in a line here. And when geologists found this, their first thought was, this might be one impactor that broke up and then boom, 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 created three craters in a row. And it's very unlikely over millions of years, especially, that you're going to create this kind of a pattern. It seems like these things should be related. The problem is that if you look at our handy geologic column, these all happen millions of years apart in the conventional story. So even though they look like they could be part of an impact chain, they can't be in evolutionary terms because they're spread out over a couple 100 million years. Now, in a flood model, we don't have that problem. So, for a creationist perspective, if it looks like an impact chain of a chain of craters, it might be one. It's a possibility. We can at least consider that possibility. Our model allows for that. Their model doesn't, right? Their model they're stuck because they have a very strict chronology of millions of years that pushes all these events apart. And that's something that happens a lot in geology, is that things that seem like they could be related in the evolutionary, secular scheme, they can't be related because they're separated by too much time. Whereas in a creation model, in a biblical model, we actually can see a lot of connections potentially between these events because we believe that many of them were happening simultaneously during the year-long Genesis flood. And that actually gives us more potential explanations than the secular geologist has because they're restricted. They have to say, okay, everything that happens, in the Devonian, that's only interacting with things that happen in the Devonian. It's not affecting what happens, above and below. It's spread out over too much time. Creation geologists, we have more options. All right, wrapping up here. I have no clock, so don't blame me if I'm late. What time is it?
8 o'clock.
Okay, all right, we're wrapping up here. We're looking at the post-flood period now. So what happens in our state after the flood, after the waters recede from the earth? And a big thing that happens, and that Missouri is somewhat famous for, is we get lots and lots and lots of caves. Hundreds, thousands of caves in the state of Missouri. And they relate, notice if you recall that map from the very beginning, that lower Salem Plateau area, that's where most of our caves are. And that's because that's all limestone primarily, which is an excellent rock for forming caves. And that limestone is uplifted, right? It's in a plateau. And that's allows us to see the caves, and it gives more erosion potential can happen in these elevated areas. I've had a chance to visit a number of caves. This is one I've not been able to visit. If you've ever heard of the Little Grand Canyon of Missouri, sometimes it goes by that name. It's Grand Gulf State Park. It's not really a Grand Canyon. It's actually just a cave. But it's a cave where the roof is collapsed. So you can actually see it if I back up here. There's the remnants of the cave. And what's happened is it's essentially a sinkhole. So the opening is from a collapse event. But you can see the cave there in the corner. You can see all the layers of limestone that make up the walls. And, superficially, it kind of resembles a canyon. So that's one. Merrimack State Park is one that I've been able to visit. Beautiful cave. It's very accessible. They have guided tours and so forth there. Onondaga Cave State Park, another beautiful one that's definitely worth visiting. It's a pretty easy hike. And one of the things we want to say about cave formation is that the traditional story that you will hear when you go to these places is going to be that these caves formed as acidic groundwater, rainwater passing through the soil, picking up acid, begins to slowly eat away at the limestone and creates these cavities. And that does happen, right? We can see that happening to some extent. But what's fascinating about these caves is notice how the bottom is kind of boring and the top is where all the topography is. Yeah. Yeah, all those little whirlpools and channels. In fact, when you look at the roof of some of these caves, the picture I got at Onondaga, you'll see whirlpools. You'll see these domes in the ceiling, none on the floor. Nothing on the floor. The floor is just flat, like following a bed plane, following a layer of limestone. And then the roof has all these channels and whirlpools and eddies and all kinds of stuff going on. I've actually asked the rangers about this, and they got no answer. I mean, it's not in their. I don't blame them. It's just not in their curriculum. They have nothing to say. But it's really interesting. What it suggests is that the water was trying to go up when it was opening up this cave, not down. And these sorts of features, these cupolas on the roofs of caves, they're found in virtually all of the limestone caves in North America. And so what this suggests, and what a lot of creationists and even some secular geologists are now thinking, is that rather than having slow dissolving of limestone from the roof, we actually have very acidic water, probably sulfuric acid rather than carbonic acid, which you would get from the roof. We have sulfuric acid, which you can get from underground, through volcanic activity, hydrothermal activity, things like that. Very acidic. It dissolves the limestone very quickly, and it's under pressure. If we imagine this is happening after the flood, you have to imagine that you've had these sediments with acidic water in them, and all of a sudden the water from the flood is retreated, and you've got a huge pressure differential, right? That everything that was pushing down on you from above is now gone. That water has to get out to equalize that pressure, and so you end up with fast flowing discharges of acidic water trying to reach the surface to relieve that pressure. And that's probably a better explanation for how many of these caves formed. It explains all the rooftop features. It explains just the enormous size of some of these cave systems. Carlsbad Caverns is a huge one. That's an example, has many of these same features. So the biblical model accounts for that, right? It would account for why we would have very sulfuric water trapped in sediments, and why that water would be suddenly need to reach the surface as the floodwaters retreated and that pressure is gone, and you would end up with caves forming very rapidly after the flood. All right, last step in our story is the Ice Age. The Ice Age is essentially it's not snowball Earth. It's not a time when the Earth's oceans froze. The Ice Age name confuses a lot of people. It's simply a time period where the ice sheets that are now at the poles moved much closer to the equator. At the north, the ice sheets to the north in particular came a long way south. And it actually turns out that the flood provides us with a really good explanation for why we have an Ice Age to begin with. In most of the secular accounts of the Ice Age, they have to cool the Earth so you can get more ice. But when you cool the Earth, you reduce evaporation. Without evaporation, you won't get the additional snowfall that you need to make the ice. So what you actually need is more evaporation, more water being pulled out of the oceans into the atmosphere. But you've got to keep that water cool when it falls on the ground. You've got to keep the continents cool so that you can actually persist each winter's ice accumulation, so it can build up and become bigger and bigger and bigger. And it turns out that the flood likely gives us that combination of contradictory features of warm oceans from volcanic activity, like we've been discussing during the flood, but cooler land masses, because that same volcanic activity, all those volcanoes, are going to be putting material into the atmosphere that is going to shield the continents from some of the sun's radiation. So your effect is that the continents are going to be cooler, not frozen, but just not as warm as they are today, even towards the equator. Whereas the oceans are warm and are giving off a lot more water in the form of evaporation. This combination of features is produced by the Genesis flood. It's not produced by the secular model. The secular model just it turns the Earth's temperature down, but that doesn't get you more evaporation. So this is actually a more powerful explanation for why we would even have an ice age to begin with. And we do believe there was an ice age. There's really good evidence when you look at this in these northern latitudes. You can see where the ice sheets have advanced and really affected the ground. In particular, as I mentioned earlier, northern Missouri there's not much there, right? It's all flat plains full of dust. And that dust is from ground up rock, because the ice, as it flows over, it's slowly flowing over the land. It is just like water. It's eroding, and it's pulverizing rock into fine powder. And then that powder is left behind, and it creates a very fertile soil, which is why we have really good growing conditions in a lot of the Midwest, is from these glacial advances. And so we have glaciers reaching down almost to the midpoint of Missouri. And one last thing, I guess I'll mention. Well, I'll skip this one. It's cool, but we've been going long enough. One more thing that I'll mention, though, is that during the Ice Age here in Missouri, other than maybe that bit of the ice that came to the northern parts of the state, overall the climate here would have been very temperate, very mild, much more like the Pacific Northwest today, like Oregon and Washington. And so very, very fertile. Lots of animals could have lived here. Would have been very well watered, and we see evidence of that at our last stop, which is Mastodon State Historic Site. And we've done some tours out there, some field trips out to that area. And that's great, because I can skip talking about it, because I can just point you to the documentary that our friend Dan Tuck has made for us. But at Mastodon State Historic Site, they found not just mastodons, but a lot of other big Ice Age mammals, Ice Age megafauna, as we call them, and those represent the kinds of animals that lived here after the flood. These animals are not buried in rock. The fossils are found just in mud banks on the sides of the river. So these are animals that migrated here after the flood and were living here in temperate conditions during the Ice Age. And then as the conditions changed, and also possibly through humans reaching the area and hunting them, they did eventually die off. And somewhere here, I think I have, down here, you can check out on our YouTube channel, we have a cool documentary that goes over this topic and also talks a little bit about the human story, because the first signs of human migrants, of humans reaching this part of North America, is also found over there at Mastodon State Historic Site. They find arrowheads along with the mastodon bones. That shows that humans have reached here. And if we think about the Bible story again, humans would have migrated from wherever the ark landed, so somewhere in the Middle East, and then they would have had to spread out across the earth, right? That's what God told them to do, right? To multiply and fill the earth again after the flood. And what you see when you look at that post-flood period, your chart there, is that the animals got the memo before man did. And we see animals spreading out, radiating across the world, across the continents very quickly, and then humans arriving behind them, which makes sense. We don't move as fast, right? Babel aside, and we don't reproduce as fast as a lot of animals do, especially the smaller ones. There's a lot of small mammals that show up really quickly, and so we can also make sense of the repopulation of the earth after the flood, even what we see here in the state of Missouri. So we wrap this all up, tie it all together. We have a real wealth of geologic and fossil information here in Missouri, right? A lot more than you might even think. And even though there's still questions that I can't quite answer yet, there's still things that need to be figured out. At a very high level, the biblical model of the flood, which is we kind of lay it out here on this card, we can explain a lot of what we see. We can explain why we see these volcanic rocks but no fossils, way down here at the bottom of our stack, and why we see all these marine animals suddenly showing up in these middle sections, in these widespread deposits of sand and mud, limestone, and so forth, including an occasional dinosaur, although not very many here in Missouri. And then we can explain the patterns we see after the flood of animals migrating into North America, crossing the Bering Strait, or maybe making their way here on vegetation mats, another possibility, and then humans finally arriving after those animals do. So we can retell that story. We can account for the much of the evidence, much of the data that we have from even secular geology and interpretation of the fossil record. We can reinterpret that in light of the biblical record. And I think that hopefully I've made the case here is that model works. We can make sense of a lot of things, and some of it we can make a lot more sense of than the secular alternative. So this framework allows us to explain the origin of our rocks and fossils, the arrival of humans, exceptional events like meteor impacts, huge volcanoes, all in the context of the Bible's record of creation, fall, the flood, and a post-flood ice age. And with that, I'm done. I'll recommend a couple resources. If any of this catches your attention or your imagination, the Roadside Geology of Missouri, which I think I have my copy around here somewhere, is a really cool book, really great resource. It has road guides. It gives you mile markers where you can see different formations. It's from a uniformitarian secular perspective, so read it with discernment, but it's got a lot of good information. For a creationist take on the fossil record in particular, I highly recommend this book by Paul Garner, Fossils and the Flood. It's the most current presentation of the fossil record from a biblical creationist viewpoint available right now.
Who's that published by?
This is published through Is Genesis History, actually. Is Genesis History.
Intensive?
Is Genesis History.
.com.
Yeah, that's where you can find it.
Okay.
And the geology timescale cards I handed out earlier, you can keep those. Those are a really handy resource we like to give out. And yeah, if you're interested in any of these resources, just see me afterwards. I can show you. And that's it. That's Show Me Geology. So, Marv.
So before we have questions, if you want to see some examples of shirts,
Yeah.
I have lots of them in my closet. I got T-shirts and I got some golf
Long sleeve
shirts.
shirts, polo shirts.
Come on now, folks.
He's trying. He's trying. Give him credit.
The Mastodon State Park.
Yeah.
They did a field trip about 2 years ago. We did a field trip down there, and I took my grandkids, and my little 3-year-old grandson Judah. We're just walking along, and they're pointing. Joel Brown and Zach, they're pointing things out, and Judah just reaches down and he picks up a rock. It was about this big. And he turned it over, and there must have been 15 fossils on the other side, brachiopods and things like that. He is so proud of that. We bought a box to put it in, and a nice piece of cloth to go underneath it. And when you open the lid, it says fossil rock found by Judah Kelsey with the date and all that. And he's taken it to show and tell at school now, and that is just. Like, that's his pride and joy.
That's awesome. And if you ever want 500 more of them, let me know. Where they, there's lots.
But
No, that's awesome.
that was a very, and I'm sure you're going to be doing that again soon, but that was really enjoyable. Really learned a lot going down there and actually physically seeing it. And when he talked about the nautiloids, there was an example of that we saw along the path down there.
That's right. Yep.
So anybody got any questions for Zach?
Mastodon State Park, how far is it from here?
It's in Imperial.
Oh, Imperial.
It's
Right off of 55. So it's, depending on where you are, it could be 30 to 45 minutes from St. Louis.
Oh,
If you're down
Right.
south, it's
And there's an actual small museum in there where they have a mastodon fossil in there, and with the history of it and all of that. It's very interesting, but you can learn the history and learn a lot by going to YouTube, put in Missouri Association for Creation, and you'll find the Mastodon Park video,
oh,
which Zach was polite and didn't pat himself on the back, but he narrates the whole thing.
great.
Zach.
I'm not sure that's a feature or a bug. Yes.
So you're saying that this was pre-Darwin, really, right? You know, the way.
So the names have changed, but
Okay,
so
so
the
they did
old
change.
names were like they had primary, secondary, tertiary, which you can see some of those old names
You
are still
see some
there.
of
So yes, the actual the science of mapping out rocks and noticing where they stood in relation to the ones above and below them, that was going on in the 1600s. Into the 1700s.
But
So
like
yes.
Cretaceous and Jurassic, are those later names?
No, a lot of those names go back. They come from specific locations, mostly in Europe.
Okay.
So Cambrian comes from Cambria. There's a lot of it was very Eurocentric initially because that's Europeans that were doing the work.
Right.
But
I
it wasn't.
remember that now.
These weren't evolutionary periods. They were just like, this is where you find this type of rock, and then noticing, oh look, if you follow it this way, this thing shows up on top of it or underneath it, and mapping those out. Nicholas Steno, who was a Christian, was really arguably the one of the founders of stratigraphy, which is what gives us the geologic column, the study of layers. And when he did that, he was thinking in terms of these rocks are from before the flood, and these rocks are from the flood, and these rocks are from after the flood. And he's still revered as the father of the science of stratigraphy, of rock layers.
Interesting.
And he assumed the Genesis flood. That was as part of his paradigm.
So a question from Dan Tuck, actually online with us tonight.
Hi, Dan.
He says, could the fountains of bursting forth from the Great Deep be related to cave formation, since you've got water coming up underneath?
Probably not, only because, so I tried to explain this and I may have gone too quickly, but the caves are formed in rocks that were laid down during the flood.
Okay.
So the rock had to be there first because the rock's been dissolved away. So the fountains, we believe, would have been taking place before those rocks were put into place. The term fountains of the Great Deep, it's a bit, still controversial in creation circles, but it's usually understood to refer to something on the sea floor, because the Great Deep, that term in the Bible refers to ocean. So a fountain of the Great Deep will be something involving the ocean, not on the land. So it's probably something going on in the pre-flood seafloor, which is destroyed, so we don't have it anymore. That's one of the challenges of, and it's actually not just creation geology, all geology runs into this, is that you're often dealing with the study of what used to be there. And that's certainly the case when we talk about the fountains of the Great Deep. We're trying to reconstruct something that, but as far as we can tell, was completely destroyed. It's like looking for the Garden of Eden, after the flood. Like, how do you even start? So probably not related to cave formation. Cave formation is probably something that happened in a burst right after the flood and then slowed down. So a lot of caves seem to have formed at the same time all over the world. And then they slowed down. And now today we see cave formation is slowed to a snail's pace. But it's, at some point, the conditions were just right, just perfect. And a lot of the big caves, at least, were formed very quickly.
Thank you.
Any other online questions, Scott?
No, that wasn't anything else.
James?
Dr. Tanford.
Oh, I'm sorry.
Yes, actually, I have two questions. One is, so there are no fossils on the seafloor can be found now?
I very, very few. Very few. And if you find them, my understanding is they tend to be found like around hydrothermal vents and places where you have kind of unusual sedimentation going on. But generally, when you find the seafloors, you have the ooze, right? You have the mud, and you have the organisms that are living there and that die there. But they're scavenged, they're decomposed. They don't. There are certain places where you might have the right conditions. Where it's there's not oxygen or whatever, and you can actually maybe preserve something. But what you find, the bedrock of the ocean is basalt. It's igneous rock. So that's the weird thing, right? It's like, why wouldn't the ocean floor be the record of previous ocean floors from millions of years? It's not. It's basalt. Even in secular geology, the ocean floor is very young. The ocean floor is just from the past, tens of millions of years instead of hundreds. So yeah, it's very interesting. Why would that happen? Why would the continents somehow become the place where the ocean leaves its record and not the oceans themselves? And the oceans in secular geology, they've been the ocean basins. So it's not like they think that the continent was once the ocean and vice versa. It's nothing like that. It's they basically have the continents acting as kind of like lifeboats, death boats, but where the remnants of the things that lived in the ocean get preserved, even though in the oceans themselves the conditions aren't right to do that.
Don't they think that the land used to be, underneath the water, right?
Yes. Virtually every part of the continents was underwater at some point in secular geology, just not all at once.
Right.
So you have lots of inland seas that are flooding different parts of the continent. So you're effectively submerging the whole Earth because it's covered in sedimentary rock, much of which was laid down by water, even according to the secular geologists. But it didn't happen all at once. So with the heresy of creation geology is we're saying, yes, these are marine sediments, and they took place because the oceans covered the continents all at once. And in fact, this entire, central core of the geologic record is all from one transgression, one flood event. And that's, the evolutionary, the old Earth geologist is basically spreading that all out over hundreds of millions of years with smaller flooding, smaller transgressions, but never covering the whole Earth at one time.
Okay, I'm sorry.
No, go ahead, James.
I did say two
You're a special guest,
so. But I inserted one, so my second question has not been asked. Well, because it seems you assumed that the rocks were made at the beginning, and they on day 3 or day 2 or day 3.
Day 3.
When the water is collected at one place, then the uplifting. Is it possible that actually that's when the rock is made instead of they were pre-made and erupted?
Absolutely. I don't know, and that's a topic that even creation geologists will go back and forth on. So the question essentially is, when God made the Earth, was there already a rocky core that was covered in water, and then God brought that above the water on day 3? I kind of like that view because it means the Earth is there's substance to the Earth. When God makes the Earth, he actually made a planet with water on top of it. Some creationists think that the Earth was nothing but water, like a ball of water. It's possible. It's possible that God made the rock on day 3 and brought it up out of the water on day 3, right? It's creation week is special, right? Because God's directly, making things. I do think that the language of gathering the water and the land appearing does suggest that the land came out of the water. Like that seems like the picture that the text is giving you is one of the water being pulled back and the land coming up out of it. So, and one thing I didn't get to talk about, but it's not just the volcanic rocks I talked about, which give you uplift, but in these same layers down here in the Precambrian, we have lots of sedimentary rocks as well, almost as though as the water was rushing off, it was eroding and dumping sediment, draping mud and sand and so forth all around the margins of the continents as it was flowing into the ocean. As the water is being gathered in one place, it was actually eroding and depositing. And that's why we do have sedimentary layers, sandstone, so forth, but no fossils, no animal fossils, no macrofossils in the same section. So that's one way of looking at it. It's possible that God has made all that in an instant in that shape. The Bible doesn't give us enough detail to be dogmatic about it. But that's the view that I like. So it's kind of like the starlight, the distant starlight issue, right? Some people say that God just made the starlight appear in the sky supernaturally, and he could have done that. But then the problem is that when we look at the sky, we see things like supernovas and galaxies that are entangled and interacting, that none of that's really real. That's just light that God made, because the stars are so far away, we never would have seen the real light from the star since God made everything. Well, it's similar here, where if God made the rocks just this way on day 3, then God made lava flows and ash flows, but they were never real. They never actually happened. He just kind of made the rocks that come from those things. We can't be dogmatic about it. It looks to me, my guess would be that God it was all supernatural. God started it. God made the stuff, but that God did use processes when he gathered the waters and brought the land out of the water, and we can see evidence of some of those processes when we look at those lowermost rocks.
The asteroids, 3 asteroids, that was along the 38th parallel in Missouri.
Yep.
You said the evolutionary model is that they could not have occurred at the same time. They happened millions of years apart. Is that because they struck different rock layers that the evolutionary model says are millions
They landed
apart?
in different stacks, different layers of the geologic column. And in the creation model, what's interesting is that we believe a big chunk of this was formed during 1 year, but we also don't necessarily believe that it was all formed in the same place at the same time, right? You could be laying down, Permian rock in one place and Ordovician rock somewhere else, right? Mm-hmm. So the possibility that an event like a chain of impacts could have preserved a snapshot where different things were being put down in different places, it's at least possible. Like a creationist can consider that. An evolutionist, that's like asking, could the moon be made of green cheese? It's not a viable thing to even think about. And so for the evolutionist, once they realized that these impacts landed in different parts of the geologic column, they just dropped that whole theory, because what's the point? Like, obviously it couldn't be related. But in a flood, it could be related. It might not be, but it could be.
That would have to be an amazing coincidence.
It would seem to, especially if some of the other ones on that map get confirmed to be impacts as well. I mean, it's really odd that you have this long line of these are all explosive structures. Mm-hmm. Like the debate is, are they volcanoes, are they impacts? The 3 in Missouri are confirmed to be impacts because they have certain minerals in them that only form with high pressure from the sky, essentially. But if any of the others get confirmed to be impacts, then that becomes even more suspicious. Yeah. It begins to look like something happened here.
Anybody else? Questions for Zach?
So there's another one online asking if the White Cliffs of Dover are made of crushed ocean shell creatures.
Yes, I don't have that in my slides because we don't have chalk deposits in Missouri. They have it in Kansas. But yes, the chalk beds, which are what make up the White Cliffs of Dover, are basically fragments of the skeletons of, I'm not sure it's crustaceans, but plankton, small marine organisms. This is what makes up your chalk. Yeah. Yep. So it's carbonate. It's limestone, really. It's just limestone, but it's limestone. It's not precipitated out as mud. It's precipitated from the shells of or like the exoskeletons, of these very small organisms. It's not like shrimp. It's much smaller than that.
That's a lot of them, though.
Billions.
Right?
And what's fascinating, again, I don't have this in I don't have any slides on this because they're not in Missouri, but deposits of chalk, like the White Cliffs of Dover, show up all over the world at one place in the geologic column. Right here at the top of the green there, the Cretaceous, that's where you find chalk deposits all over the world. They're in North America, they're in Europe. You find them all over the place, and they just show up at this one point. And the one creationist idea for this, which I think is really compelling, is that these are actually the remains of algal blooms. That after the flood, you had so much decaying organic matter, animal bodies and things mixed in the water, that you basically had conditions where you could get runaway growth of microbes, and they're just engorging themselves and reproducing on all this organic matter in the water. And then when they die, you essentially produce a blanket of this chalk mud, which then is deposited mostly on the margins of the continents. That's where you find it. And you find animals like whales buried in that, which is interesting because whales would eat, plankton, right?
Right.
And if you imagine a whale coming across, here's a swarm of plankton, this is going to be good, right? And diving in, and all of a sudden he's suffocated in his food. Not a very pleasant thought, but that seems to be what's going on. And we find these, again, on the margins of the continents. So that kind of fits with the end of the flood, that we have stuff washing up on the shoreline. But they blow up right at this one point,
Interesting.
possibly towards the end of the flood.
Thank you.
Last chance. All right, well, thanks everybody for coming. Zach, would you pray us out?
Sure. All right, let's pray. Heavenly Father, we thank you for this time we've had together this evening. I pray that some of this information has been useful, and I pray that you would help us just to grow in our understanding of your word and our understanding of your creation, and that we would glorify you through the things that you have made and through the record that you have left of how you have worked in our world, in real history, in real rocks. We thank you that your word is true, that it is faithful, and that we can rely on it, that we can stand on it. I pray that you would be with us now as we go our separate ways this evening, and we pray all of this in Jesus' name. Amen.
Amen.
Wonderful, amen.
And Scott, next month is? I know.
April.
I know. You did
Something will happen next month. I'm sure of it.
Next month's presentation is?